Hi there, everybody. This is Bill McDonald, the Common Sense Math Doctor. Today, I'm going to show you the three most difficult questions from the fourth grade math test from this past year. So if you look over here, I always got to point reverse of what I'm thinking in my head. The first question was about the flowers that 5 classrooms were making in fourth grade. The key word being 5 classrooms. The second question was your students' ability to convert cups and quarts and understand that there are 4 cups to make each quart. The third question had to do with chips. And the problem that was difficult for your kids is that the fraction of 2 of the brands of chips had denominators that were different. So they had to know how to convert fractions to have common denominators, or to be able to draw pictures that represented what the fractions looked like, so that they could at least imagine the plain chips that were being asked about. And so let's go ahead and take a look and see what I'm going to try to do in about 9 minutes. The next 9 minutes are some strategies that will help your students remember these skills for the next 9 years. I love math. I put a lot of time into it, and I feel like there's probably very few people out there that can take a question and think of something that will help your kids remember it, how to apply the skill in a very practical way, and remember it for the rest of their lives, not for the rest of a classroom. Because the percentages on these questions, the one about flowers only had 19% correct in Texas. Student expectation 4.4H. The one about conversions with cups and quarts had only 20% correct, 4.8C. And the one with fractions that had denominators that were not the same, basically subtracting with denominators that were not the same, that one got 34%. So I'm going to try my best to help you in the next 9 minutes to remember some strategies that will help your students for the next 9 years. So my time says here 7:01. So, and the time that I'm working with, so I will try to finish by 7:10 by working quickly. Here we go. All right. It was 1 and 2-step problems involving multiplication and division, including remainders. Okay. This one didn't happen to have remainders, but there was something very important that I can tell that the students did not pay attention to, which was the reason so many kids did poorly on this question. Here we go. The fourth grade classes at a school made flowers to decorate the cafeteria. There are 5 fourth grade classes at the school. So if all 5 classrooms are making flowers, we've got to figure out how to use the information that's given based on 5 classrooms, because the question is asking about every single classroom, every single one of those 5 classrooms. How many flowers did each class make? So you can tell your kids, before I can find out how many one class made, I've got to figure out how many all of the classes made. So let's see what they give us in the bullets as we follow the yellow brick road. Follow the paths, the dot paths. To make each flower, 4 sheets of paper were used. So arms, I use my fingers to do something that I call artist remember more setting. So I'm going to use the senses to draw a picture. There's a flower, and it's going to take 4 sheets. So in my picture up there, one of those flowers took 4 sheets to make. That's what they told me in the first bullet. The classes, plural, 5 of them, used a total of 300 sheets of paper. Each class made the same. That means that the flowers, the quotient will be the same for uh, each class, and for you'll take the number of flowers that all the classrooms made for step 1, and then divide it again to find out how many each classroom makes. So a lot of students struggle since we have the keyword 300 sheets and there's 4 sheets for every flower. The first thing you would say, well, what is the number of flowers that I would need for all 5 classrooms? So step 1, all of the classrooms, okay? And this is where most of your kids got it wrong, because you can see the answer A, 75, is there, but that's for all 5 classrooms. They weren't asking for all of the classrooms, they were asking for one classroom. So one of the things that I have written here is Ma's red. My mom, gets very red when I fail division. So I came up with this acronym several years ago to help kids learn a way to study division. You can see he got an F. And so the steps that you might consider following, because whatever many of you were using, either they didn't see that it had an extra step of Mas red, of division, or they didn't have a step-by-step order that they would remember. So we're going to multiply something in the divisor until we find an answer called the product. What we multiply will go on top, its answer will go on the bottom. Then we'll subtract to get an RE, a remainder. Once we do that, we'll either drop and go back to the top because there's another number, or we'll be done. So mas red. So many of you have my math posters. I would suggest that you write that down if you don't. Okay, so here we go. Going through the steps of mas red one time. Okay, we multiply 4 times 1. We're trying to make 3. No, because it's smaller, we're going to try and make 30 for our first product. So 4 times 1, our first, what we multiply is 4, the answer. What we multiply, the answer. We keep going until we get to the number that we're looking for or higher. Since we get to 32 and it passes it, we have to teach the kids we cannot go past the number. So we go to the highest one that does not go past the product that we're trying to reach. So since 7 is on the top, we put it on the top. Since 28 is on the bottom, we put it on the bottom. Then we subtract. We get a remainder of 2. Since there's a 0 there, we have to drop the 2. When you drop, go back to the top. So now we're trying to multiply to make 20, and there you see it right there. When you multiply 5, a factor, you get an answer, a product of 20. So what you multiply goes on the top, its answer goes on the bottom. You can see it's laid out right there. So we put our answer 20. Once we subtract, we get a remainder of 0, and then we're done. But because that was all 5 classrooms, we have to go ahead and go through the steps. They didn't ask for all 5 classrooms. How many flowers did the 5 classes make? 75. How many flowers did each class? So one word change changed the whole problem. Now, keep in mind that flower is not a sheet. So that means that the keywords are different. And DQ doesn't stand for Dairy Queen. If you look at my folder, my mathematics chart, if the keywords are different, we multiply or divide, and we see the word each in the question. Do we divide if we're in the question? Yes, we're going to divide that 75 that we found for our first portion by the 5 classrooms to find out how many that each classroom. So I made a shorter version of it. 5 times 1 is 5. 5 times 2 is 10, so I will go past. So what I multiply, I put on the top. My answer, I put it on the bottom. I will subtract, and I get 2 for my remainder. I drop or done, drop the 5. So when you drop, go back to the top, and then I would keep multiplying until I get to 25 or higher, my new number. My 5 goes on the top, my factor, what I multiply, and my answer goes on the bottom. My remainder is 0, and I am done. So if they asked about all the classrooms, the answer would be 75, yes. But since they were only asking about one classroom, you basically had to divide twice here. So it was a two-step problem, 2 steps of division, basically. So the answer would have been 15 flowers for each class for one class, and each being in the question DQ, divide if you see it in the question, but we'd have to divide twice because we had to first divide 300 into the 4 sheets that each flower can make to find out how many flowers. Uh, that's how many flowers that all the classrooms could make. So that would be number 1. Number 2, there were 3 quarts. It was using measurements and money, conversions, liquid, whatever. So we're going to be using measurement. There were 3 quarts of water in a container in a classroom. So artists remember more setting. So here's my 3 quarts. I just drew 3 squares. If not perfect art, but it doesn't matter. A student poured 1 and 3 cups of water into a sink. And so that means I'm gonna have to remember that my conversion rate is every quart has 4 cups inside. So I drew the 4 cups inside. Once I've done that, I can say, okay, well, they threw away 1 quart, this one here, and 3 more cups. And what they said was, how much left? Well, how much left? How much left? You subtract. And so I would take away the 1 whole cup and 3 more cups, and I would have 1 whole cup and 1 quart. And voila, the answer is right there. I am done. Last one was probably the most difficult because many kids do not know how to subtract or do comparisons when a fraction has when the fractions of 2 or 3 different numbers have denominators that are not the same. A store sells bags of potato chips. 1/3 of the bags are barbecued. So I divided a rectangle into thirds so I could imagine a picture. 1/3, 1 out of these 3 parts is barbecue. And I drew a line right down the middle where half is so I can keep that. Why am I doing that? Because 3 of the questions talk about half of the bags. And so I need to make sure I address that question about halves. 3/5 of the bags are cheese flavored chips. So I went ahead and said, okay, here's 1/5, 2/5, 3/5, 4/5, and 5/5. So 3/5 is a little bit more than half. That's important that you remember that. If all you can remember is that right there, your students would have been able to answer the question, because if I have this much of it being cheese, then less than half is going to be the barbecue and the plain ones because it says the rest are plain. In other words, whatever this is here, no, it's whatever this is here minus the 1/3 is going to be that. So if there's more than 1/2 plain, well, because more is greater than, that would not be true because more than 1/2 of the bags are cheese. So that makes that untrue. There are no plain chips. Well, uh, if I don't know how to do uh, multiplication to come up with equivalent fractions, some of your kids are going to choose that one because they won't know how to figure out how many total fractions there are. So 1/3, the multiplication property of equality says that if I multiply the top and the bottom times the same number, I want to get 15ths on the bottom, then I would have 5/15. If I take 3/5 and I want to get 15, I multiplication property of equality. If I multiply 3 on the top and 3 on the bottom, that's 9/15. And I know that this is probably not a fourth grade objective, but letter B is going to be a hard one if their kids cannot figure out how to do this. So that means that I would have 9/15 being cheese plus 5/15 being barbecue, which means 9 plus 5, 9, 10, 11, 12, 13, 14, 9. I even did my uh, addition wrong. That 14/15ths are barbecue or cheese, which means that only 1 out of 15 are left to be plain. Okay, so if they can learn how to do the multiplication property of equality with fractions, they'll be able to figure that out. And I think that since your kids do know how to multiply up to hopefully 12, they could understand that whatever you do to one side, you also do to the other. Exactly 1/2 of the bags are plain. No. If more than half of the bags are cheese, that means that less than half of the bags are going to have to be plain. And that's exactly what we have for our answer, that less than half of the bags are plain, only 2/5 out of the bag. So if you think of the number 5, 2.5 out of 5 is half, because 2.5 is half of 5. And since there's only 2/5 less left after we take out the cheese bags, then we can see that that is true, that less than half of the bags are plain. So the answer is going to be D. And so your kids are at least going to have to draw pictures, but something that you can do if you have my mathematics chart, I have fifths here on in the decimal fraction portion. So if you count 1/5, 2/5, 3/5, 4/5, 5/5, there's 3/5 right there. And since I have here tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, since 5/10 is the same as half, since the cheese bags took up more than half of the chips, that means that less than half would remain for the plane. And then I went ahead and drew a picture. I just divided that same space into 3 equal parts. So we can say, okay, here's my barbecue. There's 2/3 and there's 3/3. So that's what I would recommend that you do, is have some sort of chart where the kids can get used to working with fractions that have denominators that are not the same, and they're going to have to start multiplying up to 12 to get fractions that have the same denominator, what we'll call equivalent fractions, because as you saw in the work that I did, that 1/3 is the same as 5/15, and 3/5 is the same as 9/15. And once you add that up, you'll be able to see that, yes, it's definitely only, I did that right. Let me see, 9 plus 5, yes. They're only 9, 10, 11, 12, 14, only 1/15 of the bags, 1 out of the 15 bags, or 1/3 of, 1/15 of the bags would be plain. So it's 719. I can't remember. I think I made it because I think I said I was going to start at 711, but I'm wrong. Please forgive me. I hope that you enjoyed the video anyway, and that you'll be able to apply some of these strategies with your kids. God bless. Please share this math video with your 4th and 3rd and 5th grade math teacher friends, because some of these are supporting and some of these are readiness standards in 4th grade.